Hi, everybody. I'm Nathaniel Baeumler. I am a graduate student. This is my first year. I work in the Soil, Water, and Climate Department, and I teach group as my advisor. I'm native to Minnesota, but I spent 5 years in Germany. I think that's important because that's where I really started to get interested in the environment. And then I came back to Minnesota and did my undergraduate career here in environmental sciences, policy, and management. And during that time period, you're required to do an internship. And I was very fortunate enough to do an internship at the Mississippi Watershed Management Organization. And I had a wonderful experience, and I really got interested in urban stormwater management and water quality in urban areas, and just water quality in general. So what are my interests? I'm very interested in generating the appreciation and understanding of our water resources. I think a lot of it is taken for granted, and bringing that appreciation to the public is very important, both for point and non-point source pollution, and then we can use that in stormwater management and other things to create a better environment. I'm driven by the understanding that we really do only have one planet, and we do need to take care of it and leave it better than we found it. And the goals for my master's thesis are to understand the issues surrounding water, sediment, and nutrient patterns in relation to climate and land use changes. In addition to that, we're also looking at quantifying the relative changes in evapotranspiration from prairie and crops. So the first project I worked on was actually as an undergrad with Satish, and we looked at the changes in stream flows in eastern South Dakota on an annual basis. It's well known that tile drainage has increased in the upper Midwest, and the concern is that tile drainage is causing increased stream flow in these rivers. Our analysis looked at these issues, and it showed that the increased stream flow is really related to the increased precipitation that we've been receiving. We're getting higher, or back-to-back high precipitation rainfalls are becoming more and more common, and it's causing the rise in soil moisture and the filling of the storage of the soil. And we found that 9 out of the 10 watersheds we looked at, 1 year prior's precipitation, in addition to the current year's precipitation, is affecting the current year's stream flow. My main project for my thesis, we're looking at something kind of similar. We're looking at climate and land use changes on stream flow and nitrogen loads in the Minnesota River Basin. Along with stream flow and base flow, we're looking at nitrogen and fluidic concentrations and loads. The independent variables we're looking at in our regression model right now are monthly and annual precipitation, along with the soybean area. Just like eastern South Dakota, we found that stream flow and base flow are really connected to precipitation of the current year or month, and then the prior year's precipitation, in addition to prior month's precipitation, depending on if you're doing it on a monthly or annual basis. The fluidic concentration was really hard to come up with variables that show the variance. Mostly we didn't find any connection with the variables that we've looked at, but in some months we did find a connection, and it was really the current month's precipitation or the current month and maybe the 1 or 2 months prior. That really shows what the fluidic concentration is doing. The nitrogen loads, we did find a relationship between precipitation and the soybean area. However, soybean area has only shown about 8% of variation in the data so far. The last thing we're looking at is the evapotranspiration of prairie grasses. We're using the metric model, which was developed by the Idaho Department of Water Resources. We're working with Java Kjaersgaard right now to look at just understanding the evapotranspiration of prairies. This is important because there's a significant lack of data in understanding what the ET potential of prairies is, and so if we can figure out what the ET of prairies is, we can further understand land use effects in Minnesota. Thank you. So this is the project we have not really had a lot of time to look at yet. So this will be a future project that we're looking at.
Are you planning on measuring this?
Yes. So the metric model from what I've read so far, looks at the solar energy balance at the atmosphere and the surface, and we use those calculations to determine the ET. The images we use, so we're using satellite imagery from Landsat 7 and Landsat 8, and obviously the imagery is one moment and one time of any given year that we're looking at. So we're looking at 2015 and 2016 of 2 days in each of the growing season months. So then we'll be able to get ET of that moment of a pixel on the landscape, which will then be able to help us understand ET, because we'll be able to extrapolate that maybe to the system. But we have weather data that we have to input, so the system is the mapping, evapotranspiration, with internalized calibration. So we have weather data that we've gotten from nearby airports, and we've used that. It's on a 20-minute time scale to be able to help really hone in on the variability that the model could produce.
It's in the context that people have been saying before immigrants came over here, there were a lot of rains, there were a lot more evapotranspiration, and there's not enough data. So Nathaniel has worked for about 4 months in the Epic class card, who has used this method and developed this map. And looking at the land use pictures, you can estimate what will be the ET. So we have a great natural prairie area, a lot of water, and our images are we're gathering those images from the past and compare with the past.
Yeah. Your decision to use soybeans, is that because that's extreme, or is that, I'm not sure how that falls in relation to the prairie?
So this is not related to, I understand.
Yeah.
So like Satish was saying, the landscape used to be highly dominated in prairie, and now it's becoming more highly dominated in row crop, including soybean. And so we're looking at, has the ET really changed that much from prairie to row crop systems of today?
Why soybean instead of corn?
Yeah, why did you use soybean in the regression?
Corn has been relatively stable for a longer period of time, and soybean really took off between the 40s and 70s, and the stream flow that we're looking at also has taken off since the 70s, and so we're saying that maybe that is some of the reason, and the literature is pointing to soybean as one of the major drivers of changes in stream flow.
I think the last part is a lot of people were saying that we used to have small grains, and they are growing earlier part of this year, like March, end of March to April. So they are saying there was a lot more evapotranspiration at that time, and the soybeans are planted, which are replacing small grains planted like mid-May. And so we are missing that, and that's why we have more stream flow. But if you look at it on an annual basis, if you have earlier small grains, then later in the growing season, like in summer, we don't have anything growing, we're going to have a lot more water stored in the soil, and that's going to go in the river. That's not what's happening. So we need to address that. Any other questions for Nathaniel? Thank you, Nathaniel.